Hello guys, welcome back to Mathzone African Motives. Still working on mathematics in 5, working on our integration. We are going to be focusing with this integration, which represents the logarithmic form of an integration. What type of integration are we talking about in this case? We are referring to an integral whereby you have the f of x in the denominator. And this f of x is corresponding to its first derivative as long this part in the numerator is representing the first derivative of f of x. Then our answer is going to be ln f of x, which is this function that we are given here, plus the constant of integration. Ln f of x, ln f of x, the denominator, the one that gave us what? The derivative in the numerator. So this derivative that the basic integral that you're going to make, as long the denominator, if you differentiate it, it gives you what is in the numerator, then your answer is going to be ln f of x plus c. How do we apply this? That is the question now. All right, let us take a consideration of these typical questions that I'm having. Let's say, for an example, we are given to integrate the tan of 2x in this case with respect to x. All right. If we are to take into consideration, remember from our trigonometry, you know that tan is sine over cos. So to have as a fraction, we're going to have the integral of the sine of 2x in this case over the cosine of 2x with respect to x. All right. So I talked about such integrals where you are given f of x and its derivative. On that condition, focus on f of x. You keep your focus on f of x. The denominator is the one that is representing f of x. So work from there to say, you know that your f of x there is the cosine of 2x. What is supposed to be its derivative? This is the question. What is supposed to be the derivative of cos? Remember, cos here we're going to multiply. It's going to be negative 2 the sine of 2x. This was supposed to be the term or the expression on the numerator here to represent our first derivative. But if we check, it is not the one. Here there is sine 2x. But our derivative, it's minus 2 sine 2x, meaning to say here we are supposed to have a negative 2. So that this represents f of x and this represents its derivative. But how are we going to do this so that we have a negative 2 on our sine x? We are going to multiply this by negative 2 over 2. All right. By multiplying by negative 2 over 2, we are simply multiplying by 1, so it does not affect our question. So what I'm trying to say is that this term on the numerator is not our corresponding first derivative. We are in shortage of the negative 2. So you multiply by negative 2 over negative 2. What are we simply doing? Remember, a constant, when multiplying an integral, it can be taken inside of the integral. So this was supposed to be given as, if we take minus 2 inside, it means we are going to remain with 1. So this one is going to be 1 over minus 2, of which 1 over minus 2 is same as minus a half in this case. We are now having the integral of, we have taken the negative 2 inside here. So it's going to be negative 2 the sine of 2x over the cosine of 2x, which we haven't changed anything because minus a half, this one times this, it gives us a 1. Meaning to say we haven't changed our expression. By multiplying by 1, it does not affect our given expression. So our concept is that this is our f of x, and this is the corresponding f of x as we saw here, the derivative of cos 2x, it's minus 2 sine 2x. So the law states that if this is representing f of x and this is the corresponding derivative, the answer is going to be ln f of x, which is ln of the function. So we're going to have minus half ln of our f of x. Our f of x is what? It's cos 2x. So it is going to be ln cos of 2x in this case, plus the constant of integration. That's it, we are done. So the idea here, the idea is that the f of x must correspond to the first derivative. If they do not correspond, make them to be the same. just multiply by the term that is there that is affecting your solution. That is how you play around with this. All right, let us have this. All right, I don't want to get rid of my formula here so that we do not confuse each other. So I'm going to maintain this formula here. Let me have the other person on this part so that we see the formula and how to play around with our formula in this case. All right, let us say we are given another integral in this case. All right, let us say we are given the integral of 1 minus the sine of 2x, everything over x squared minus sine squared x with respect to x. So as you can see already here, we are given it as a fraction. So like I said, once you have a law or a condition to work with like this part, check your f of x, relate from f of x. So this is our f of x in the denominator. F of x is the one that is in the denominator. So you ask yourself, if my f of x in this case is given as what? Is given as x squared. All right, this is x, not x squared. X here, sorry. This is x here. Sorry for this one. It's supposed to be x minus like this. All right. So if my f of x is in this case is equal to x minus the sine squared of x, what was supposed to be the derivative? This is how you ask yourself. What is supposed to be the derivative of this f of x? Let us find its derivative. The derivative of x here is a 1. Then we've got the derivative of sine squared x. Remember, this is same as sine x like this squared, where you differentiate the outer bracket, which is you drop the exponent minus 2. The sign remains as it is like this, but now to the exponent of 2 minus 1, which is 1, times the derivative of sine x, which gives us cos x. Remember from our function of a function concept, of which sine x to the exponent of 1 simply gives us what? The sine of x times the cosine of what? Of x here. So this is our first derivative, which you can simplify. Remember from our identities, guys, 2 sine x cos x like this whole part is equivalent to sine 2x. All right, we know that the sine 2a is equivalent to 2 sine a cosine of a, and this is what we have. We've got x, just gonna put x and x. So meaning to say this was going to give us 1 minus sine 1 minus sine 2x here, 1 minus the sine 2x, just like 2a. So this was going to be 2x. All right. So this is how also you can play with your identities to obtain a single a trig expression in this case. So we have the first derivative, which is 1 minus 2x, 1 minus sine 2x in this case. Let's check what we have on the numerator here. On the numerator, our first derivative, this is what we have on the numerator. We've got 1 minus sine 2x, which is exactly the same as this one. So these two, they are directly corresponding. So meaning to say our f of x here is giving us directly the first derivative. There's no need for us to adjust anything, just like the previous part where we're multiplying by minus 2 over 2. There's nothing that we are going to do. It's directly the first derivative. The denominator here is our f of x. The numerator is our first derivative. So the answer is going to be ln f of x, which is our denominator here, which is ln of x squared. Ln of x, sorry, I'm still in mind with x squared. So it's going to be ln of x minus sine squared of x in this case, plus what? All right, so here we are going to add our constant in this case. All right, so we are going to add our constant of integration. So that was the whole part of this integral. So this part that we are having on this side is to test and see if this is giving us directly the first derivative, because sometimes you might not have a direct derivative like what we saw in the previous case where we need to have adjustments, but that is the application of our logarithmic part in terms of our integrals in this case. All right, so like I said, I want to maintain our formula so that we do not confuse each other. Let's say we are given again to integrate the cosine of 2x over the sine of x, in this case, the cosine of x like this with respect to x. All right. The first thing that we are supposed to take into consideration here is that before we talk about the derivative, because here we are supposed to apply a product here in order to differentiate both this or f of x. But there's something hidden about this cos 2x here. And this sine x cos, there are some identities hidden there. Remember the identity that we just talked about previously. We said the sine of 2a, all right? Well, let us write in terms of x so that we do not confuse you. So that I do not confuse you, let me write in terms of x. The sine of 2x is supposed to be equivalent to the 2 sine of x, the cosine of x. And we see that here there is sine x cos x. Here there is sine x cos x. What is it about these two? It means if I can multiply this term by 2, it is going to be 2 sine x cos x, which is going to give us what? Which is going to give us sine 2x. But we do not just multiply here by 2. Whatever that we do here must also be done on the numerator also. So meaning to say this whole part was going to change into the integral of 2 cosine of 2x like this over 2 sine of x cosine of x. Take note, this part here is equal to 1. It does not affect our question at all because it goes back to the original term. But you do not cancel because what you want is to take this part, 2 sine x cos x, which is the part that you know it is equal to what? 2 sine x cos x. We say the whole part is equal to sine x, sine 2x. So it can be written now as the integral of, all right, with respect to x here. So it's going to be written as the integral of 2 cosine of 2x over this whole part now as a single trig. It's sine 2x. So this is going to be sine 2x like this with respect to x. So this is what we're going to have at the end. So they just wanted to play around with us here to say, now with this now, test back to that part that I was referring, because you can tell from your denominator here, this is our f of x. So our denominator is our f of x. We are going to test if they correspond. Our f of x is equal to the denominator, which is the sine of 2x. In original sense, what was supposed to be the derivative of this, because we are supposed to talk about the derivative there. So the derivative of sine 2x, remember, multiply here, which is going to be 2. It changes to cos, which is cos 2x. So this is what we have, 2 cos 2x. And here we also have 2 cos 2x. So these two, they directly correspond, meaning to say this, our f of x is corresponding to its first derivative. There is no adjustment that we are going to make because they are directly the same. So we saw that if the f of x is corresponding to its first derivative, the answer is going to be ln f of x, which is ln of our f of x, which is our denominator here, which is the sine of 2x in this case, all right, which is the sine of 2x, ln sine 2x plus the constant of integration. That's it, we are done. We have integrated this whole part. So it's all about knowing the laws that you are given, working with your trig, because sometimes, as you can see, it's not like you're going to obtain something that is direct. Like this person, you are supposed to make adjustments before you talk about this concept. So that is how they try to play around with your minds, guys. You have to be very, very careful on how they try to play around with these questions. But as we can see, the idea there still remains the same. You need to know your f of x and your corresponding function, which is its first derivative. All right, let us have another question again. The integral of e to the exponent of 3x, everything over 1 minus 6 e to the exponent of 3x like this with respect to x. All right. Still applying our same concept, we've got a fraction in this case. So you can think of this concept whenever we've got a fraction like this. So knowing that, the first thing to think of is our f of x. I'm going to take my f of x. The f of x that we have, it's 1 minus 6e to the exponent of 3x. What was supposed to be its corresponding first derivative? That is our question now. What was supposed to be the first derivative, all right? Here there's a 1, derivative of 1, that's a 0. We move on to e. Remember, if you are differentiating the derivative of e to the exponent of f of x, I said, is the first derivative of x times e to the exponent of f of x, meaning to say you differentiate the function here, multiply it. So you're going to, the derivative of 3x is 3. So you multiply to -6, which is going to be -18. We said 3 times this, which is -18. Then e to the exponent of f of x, meaning to say e to the exponent of 3x like this. All right. This, guys, was supposed to be our first derivative, this one. This is what we are supposed to have on top here. But if we check on our first derivative on top here, we are not having this -18. So meaning to say on this one, we are supposed to make adjustments so that we can have -18 on top here, so that it must correspond to say this is the f of x, then this is the first derivative, but being on top. So there we are supposed to make adjustments, which is multiplying by what? By -18 over 18, which does not affect anything. That is the integral of e to the exponent of 3x over what? 1 minus 6 e to the exponent of 3x with respect to x. So by multiplying by this, we simply want this -18 here to multiply what is on top. And the moment we do this, we are going to remain with a 1 because we have taken this inside. So we're going to remain with -1 over 18 into -18 taken inside. So it will be -18 e to the exponent of 3x like this. Everything over what? 1 minus 6 e to the exponent of 3x with respect to x. Now we can see that, all right, what we have in the denominator here is this part, which is our f of x, like what we had before. And what we have in the numerator here, which is -18 e to the exponent of 3x, -18 e to the exponent of 3x, is the first derivative. So they do correspond to say this is our f of x, and this is its derivative. When it is like this, that this is f of x and this is its derivative, use this log on your answer. So therefore, our answer is going to be -1 over 18, which is outside the ln of, so it's going to be ln f of x, which is our f of x, our whole denominator, 1 minus 6e to the exponent of 3x. So remember, this is our f of x, in this case, 1 minus this, then plus the constant of integration. We are done. So that is the whole idea. They are going to have repetitions and repetitions, trying to play around with us, trying to confuse us along the lines with the given expressions. But the idea there is simply knowing your f of x and its corresponding derivative. That is how we attempt these typical questions. All right, another question we are given here, e to the exponent of 4x minus the sine of 4x, in this case, everything over e to the exponent of 4x plus the cosine of 4x with respect to x in this case. So this is what we're asked to find. All right, to integrate. So as we can see, we've got a fraction and we can't combine anything here. So we just have to take our f of x, which is the denominator here, and test what was supposed to be its first derivative. Our f of x is e to the exponent of 4x plus the cosine of 4x. All right, so what was supposed to be the first derivative? All right, I talked about e, guys. You just have to find the derivative here, which is 4. You multiply to this term. E to the exponent of 4x remains as it is, all right? Then cos, remember, it changes to sine, but you have to multiply by this constant, so that's -4, the sine of 4x. This is what we're supposed to have. And if we check here, there is e to the exponent of 4x minus sine 4x. So meaning to say here, we can just factor out 4, which is common. That is the first derivative with respect to x is going to be 4 into e to the exponent of 4x. We divide 4 and 4, we remain with the minus sine 4x, so that we can properly see the e to the exponent of -4x here, which is the same as this part that we see here. But here we can check on the numerator. What just affected is that we do not have this 4, because as we can see, there's a 4 that is there on our actual first derivative. We are having a 4. But on this question that we are given, the 4 is not there. So what happened? They just took out that 4. So how do we bring out that the 4 that was not there? We simply multiply by 4 over 4 so that we obtain the 4 on top. This 4 is going to multiply the top part, meaning to say we are going to remain with 1 over 4 in this case. The integral of 4 multiplying everything on top. So it is going to be 4 into e to the exponent of 4x minus the sine of 4x in this case. Everything over what? Over e to the exponent of 4x plus the cosine of 4x with respect to x. So as we can see, this is our f of x, and this is its corresponding first derivative, the one that we see here, that is its derivative. So we are back. F of x, its corresponding first derivative. What is supposed to be the answer? The answer is supposed to be ln f of x. So it's ln f of x, which is our denominator here. So it's going to be ln of e to the exponent of 4x plus the cosine of 4x in this case, plus the constant of integration. All right, so that is the whole idea of this logarithmic part whereby we are dealing with it into our integration, and we have to make the denominator to obtain a derivative which is corresponding in the numerator. Its derivative must be exactly the same as what you have in the numerator. So you have to make adjustments for that part that is not the same to make it the same as the answer that you are supposed to have for that derivative. Once you have that condition, apply the concept here, ln f of x in plus what? Plus the constant of integration. You're done. So those are the typical questions. Like I said, they will try to play around with you along the lines, but it's actually nothing. Maybe we can just have a last question to consider, which is the integral of x squared minus cosec. So this is cosec squared 3x everything over x cubed. So we are given x cubed plus cot 3x plus cot 3x with respect to x. All right. So as we can see, we've got the same, we've got a fraction. So we try to check if this and this do correspond in terms of being the f of x and this being its derivative. So we are back to the testing part. Our f of x being our denominator here is equal to what? X to the exponent of 3 plus cot 3x in this case. What was supposed to be its derivative, all right? So differentiate here, drop the exponent, that's 3x to the exponent, subtract 1, which is 3x squared. Remember, cot changes to a cosec squared being a negative. So having a 3 here, so it's going to be minus 3 cosec squared 3x like this, all right? 3 is common on this part, so we can factor out 3. We remain with x squared minus cosec squared 3x if we factor out this 3, which is common. So this is supposed to be the exact first derivative of this f of x that is in the denominator. But if we check on our numerator here, we do not have it exactly this way. Because of what? Because of this 3 that is missing. So how do we bring these 3? Simply multiply by what? By 3 over 3. And take this 3 inside to multiply on top so that you obtain exactly this this derivative that we obtained. So this is going to be 3 into, all right, moment we take this, the moment we take this 3 inside, we remain with what? 1 over 3. The integral of 3 is now inside. So it's 3 into x squared minus cosec squared 3x. There's nothing that you're simplifying there. It's just rewriting. That's your only part to rewrite as it is with respect to x. So by rewriting, we can see that this part here is the same as this part, which is our first derivative. So that means our f of x is corresponding to its first derivative. So therefore, our answer at the end is going to be what? A third ln f of x. We are now back to the solution, how it is supposed to be given as, which is ln f of x. Our f of x is our denominator here, which is x cubed plus the cot of 3x in this case, plus the constant of what? Integration. So that is how they will play around with us. They will play around through this concept. Once you are having a consideration of having your f of x corresponding to its derivative in the numerator, as long they do correspond to say f of x is in the denominator, but the first derivative is in the numerator. You do not work out anything. The answer is just taken from your formula. So all you need is to know the arrangement of this side and the arrangement of the final answer, how it is supposed to be given as. So these are the typical questions that you'll be having in your final exams. Let us try to revise as much questions from our past exam papers and see how do we attempt this this type of integral. But for now, guys, that's it for Meson African Motives. Till we meet again.